Now, moving on to metric conversions. When converting between units of measurement, there are two calculation methods that can be used. We have the ratio and proportion method, or dimensional analysis, that DA. Now, each method requires that you know basic metric conversions. For example, you already know that 1 gram equals 1,000 milligrams, or 1 milligram equals 1,000 micrograms. Or a liter, for example, that's 1,000 milliliters. Now, weight is often converted from pounds to kilograms for dosage calc. So 1 kilogram is 2.2 pounds. And that's a very important conversion to memorize. So for dimensional analysis, or DA, this is a calculation method that uses a series of equivalent conversion factors for one system of measurement to another. However, DA does not require you to memorize specific formulas. So this calculation method reduces errors and can be used for all dosage calculations in nursing practice. Now, the steps when setting up an equation using DA are as follows. First, start with the unit of measurement, or label it as needed in the answer. For example, if the question is asking us to determine milligrams per dose, then this is the starting point, and it's expressed as follows here. So first, we have X milligrams per dose because we're solving for X. And for example, we set up all the calculations almost like targets in a row. So this is where you build the equation by placing information with the same label on top and on the bottom, so they can simply cancel each other out. So remember to repeat until all the units of measurement are not needed in the answer, as they are canceled out here. So we're going to practice specific questions, but just to show you here. Once all the targets are set up like this, then simply calculate to determine the correct labeling for the numeric answer. So, for example, multiply all the top numbers, the numerators, on top, and then multiply all the bottom numbers, the denominators. And after that, we simply divide the top number by the bottom number. And voila, you answered the whole question correctly here. Now, starting with question 1, using the ratio proportion method, convert 6,000 milligrams to grams, and calculate the answer and record it using a whole number. So first things first, we're setting up the formula here, right? So we're determining 1,000 milligrams equals 1 gram, because you memorized this. So set up the equation here. So what's the relationship between milligrams and grams? Well, as you know, 1,000 milligrams is 1 gram. Or simply put, 1,000 milligrams over 1 gram. This is what you know. Now, what are you trying to calculate for? Well, we're trying to calculate for 6,000 milligrams for X grams, or 6,000 milligrams over X grams. This is what you need to determine. So place what you know on one side and what you're trying to determine on the other side here. So 1,000 milligrams over 1 gram and 6,000 milligrams over a gram here. So your equation is set up correctly if the labels for the numerators are identical while the labels of the denominators are also identical. Now drop the labels here. So we have 1 over 1,000 and X over 6,000. So simply solve for X by cross multiplying. So 1,000, that X, equals 1 6,000. Or basically 1,000x equals 6,000 here. Now isolate the x by dividing both sides by 1,000. So 1,000 divided by 1,000 is just 1, and 6,000 divided by 1,000 is 6. So our correct answer here is 6 grams. Now question number 2. Use dimensional analysis to convert 0.8 grams to milligrams, that mg. Calculate the answer and record it as a whole number. So first things first, set up your formula. We know that 1 gram equals 1,000 milligrams, or 1 gram over 1,000 milligrams. And what are we calculating for? Well, we're calculating for X milligrams. So setting this up, 1,000 milligrams over 1 gram, and on the other side, we have 0.8 grams. Now we just multiply across. 1,000 times 0.8 is 800, and 1 times 1 is just 1. Now we just simply divide. 800 divided by 1 here is 800. So the answer is 800 milligrams. Now moving on to question 3. Using the ratio proportion method, convert 430 micrograms to milligrams, that mg. And we're answering it and recording it to the hundredth place here. So set up the equation using the ratio proportion method. What is the relationship between micrograms to milligrams? So as you know, 1,000 micrograms equals 1 milligram. Or simply put, 1,000 micrograms on top and 1 milligram on the bottom. This is what you know. Now, what are we trying to calculate for? Well, 430 micrograms equals x milligrams. So 430 on top and x mgs on the bottom. This is what we need to determine. So place what you know on one side and what you're trying to determine on the other side. So 1,000 micrograms over 1 milligram equals 430 micrograms over x milligrams. Now we simply drop the labels, 1,000 over 1 and 430 over x. And solve by cross-multiplying here. So 1,000, that x, equals 430, that 1. Or basically, 1,000x equals 430. Now isolate by dividing both sides by 1,000. So for example, 1,000x over 1,000 is 430 over 1,000. So 1,000 divided by 1,000 is just 1, and 430 divided by 1,000 is 0.43. So x equals 0.43 milligrams. So our correct answer here is 0.43 milligrams. Now moving on to question 4. Using dimensional analysis, convert 4 milligrams to micrograms and calculate and record it as a whole number. So let's set up our formula here. We know that 1 milligram equals 1,000 micrograms. Simply put 1 milligram on top and 1,000 micrograms on the bottom. Now, what are we trying to calculate? We're trying to calculate micrograms, right? So x micrograms equals 1,000 on top and 1 milligram on the bottom. Now we multiply this by 4 milligrams on top. So now that everything's set up, we can simply multiply across. So 1,000 times 4 is 4,000, and 1 times 1 is just 1. Then we simply divide. So 4,000 divided by 1 is 4,000. So our correct answer is 4,000 micrograms. Now for question 5, using the ratio proportion method, convert 200 micrograms to milligrams. So setting all of this up here. First, we need to identify what we're solving for in the question, and then set up the equation. As we know, 1,000 micrograms equals 1 milligram, or basically put 1,000 micrograms over 1 milligram. This is what you know. Now, what are you trying to calculate? Well, 200 micrograms equals x milligrams. So 200 over x milligrams. So we simply put 1,000 micrograms over 1 milligram and 200 micrograms over x milligrams. Now we drop the labels. So we have 1,000 over 1 and 200 over x. And then we solve for x by cross-multiplying. So 1,000 with x in parentheses and 200 with 1 in parentheses. So 1,000x for 200. Now isolate the x by dividing both sides by 1,000. So 1,000 over 1,000 and 200 over 1,000. We simply get 1,000 divided by 1,000 is 1, and 200 divided by 1,000 is 0.2. So x equals 0.2 milligrams. So the answer here is 0.2 milligrams. Now for question 6, the provider prescribes 45 mLs of Zithromax for a client with sinusitis. The medication is to be given at home, and the client only has the ability to measure in ounces. How many ounces are in 45 mLs? Okay, first things first, for dimensional analysis here, we're setting up that relationship. So, what's the relationship between mLs and ounces? Well, we know that 30 mLs equals 1 ounce, or basically 30 mLs over 1 ounce. Now, what are we trying to calculate for? We're trying to calculate for X ounces, right? So let's set it up. X ounces equals 1 ounce over 30 mLs times 45 mLs. Now we simply multiply straight across. So 1 times 45 is 45, and 30 times 1 is just 30. Now we simply divide those top numbers from the bottom number here. So 45 divided by 30 is 1.5. So our correct answer here is 1.5 ounces. Now, moving on to the next question here, the provider prescribes 2 teaspoons of acetaminophen, that Tylenol, for a child with a fever. How many mLs does the nurse administer to this client? Calculate your answer using dimensional analysis and record it as a whole number. So what is this question asking us for? The question's asking us to convert teaspoons to milliliters. So as you know, 1 teaspoon equals 5 mLs, or basically put 1 teaspoon over 5 mLs. Now let's set up our equation here. What are we calculating for? We're calculating for mLs. So we put X mLs equals 5 mLs over 1 teaspoon times 2 teaspoons. So now that everything's set up, we simply multiply across. So 5 times 2 is 10, and 1 times 1 is 1. Next, we simply divide the top number by the bottom number. So 10 divided by 1 is simply 10. So the correct answer here is 10 mLs. Now moving on to the next question. The nurse measured a wound and documented its size as 35 mm, or basically 35 millimeters. The healthcare provider, the HCP, requests that the measurement is in cm, centimeters. So how many centimeters are in 35 millimeters? So we're calculating the conversion using a ratio proportion method and recording the answer to the nearest tenth place. All right, so let's set this up for ratio proportion. So we know that 1 centimeter equals 10 millimeters, or basically 1 centimeter over 10 millimeters. Now, what are we trying to calculate for? We're trying to calculate for centimeters. So we put 35 millimeters, or basically 35 over x centimeters. Now we place what you know on one side and what you're trying to calculate for, or basically determine, on the other side. So 1 centimeter over 10 millimeters and x centimeters over 35 millimeters. Next, we just drop all the labels here. So 1 over 10 and x over 35. Now we solve for x by cross-multiplying. So 10 with x in parentheses equals 35 with 1 in parentheses. So 10x equals 35. Now we isolate by dividing both sides. So it should look like this: 10x over 10 and 35 over 10. So 10 divided by 10 is just 1, and 35 divided by 10 is 3.5. So x equals 3.5 centimeters. So the correct answer is 3.5 centimeters. Moving on to the next question here. The provider prescribes 1.5 liters of normal saline to infuse for a client with dehydration. The nurse needs to convert the liters to milliliters, those mLs. How many mLs are in 1.5 liters? So we're going to be calculating this using dimensional analysis and recording the answer as a whole number. So first things first, what do you know? You know that 1 liter equals 1,000 milliliters, or simply put, 1 liter over 1,000 mLs. Next, we're setting up the equation. So what are we calculating for? We're calculating for x mLs. So x mLs equals 1,000 mLs over 1 liter. And we're multiplying that by 1.5 liters. Now that everything's set up, we simply multiply across and multiply on the bottom. So 1,000 times 1.5 is 1,500. And on the bottom, 1 times 1 is just 1. Now we divide. 1,500 divided by 1 is 1,500. So the correct answer is 1,500 milliliters. and 850 divided by 1,000 is 0.85. So the correct answer here is 0.85 liters. And 850 divided by 1,000. Now for the next question. The provider prescribes 850 mLs of polyethylene glycol for a client who's scheduled for a GI diagnostic test. The nurse needs to prepare the medication and is stocked in liter containers. How many liters will the nurse prepare for the client? So remember, we're going to calculate the liter that is required using the ratio proportion method and record the answer to the nearest hundredth place here. So let's set up what we know. We know that 1,000 mLs equals 1 liter, or simply put, 1,000 mLs over 1 liter. Now think about what you're trying to calculate for. 850 mLs equals X liters, right? So basically, 850 mLs over X liters. This is what we're trying to determine. So place what you know on one side and what you're trying to determine on the other side. So 1,000 mLs over 1 liter and 850 mLs over X liters. Now drop all the labels and we get 1,000 over 1 and 850 over X. Then simply solve for X by cross multiplying. So 1,000 with X in parentheses equals 850 and 1, right? Now isolate the X by dividing both sides by 1,000. So 1,000 divided by 1,000 is just 1, and 850 divided by 1,000 is 0.85. So the correct answer here is 0.85 liters. Now for the next question. The provider prescribes 2 tablespoons of cough syrup for a pediatric client. For accuracy in the home, the nurse educates the child's caregiver to administer the medication in mLs. So how many mLs will be administered to the child? Now we're going to be using dimensional analysis. So as you know, 1 tablespoon is 15 mLs, or 1 T on top and 15 mLs on the bottom. Now let's set up the equation. What are we trying to calculate for? We're trying to calculate for X mLs. So we put 15 mLs on top and 1 tablespoon on the bottom, times 2 tablespoons on top on the other side and X on the bottom. Now that everything's set up, we simply multiply across. So 15 times 2 is 30, and on the bottom, 1 times 1 is just 1. Then simply divide. 30 divided by 1 is just 30. So the correct answer is 30 mLs. Now for the next question. The provider prescribes 5 teaspoons of lidocaine for a client diagnosed with stomatitis. How many mLs does the nurse administer to the client? Now we're calculating using the ratio proportion method and record it as a whole number. So first things first, what do you know? You know that 1 teaspoon equals 5 mLs. Basically 1 teaspoon over 5 mLs. And what are we trying to calculate for? Well, we're trying to calculate for 5 teaspoons, right? So this is X mLs, or 5 teaspoons over X mLs. Now let's set up the equation here. So 1 teaspoon over 5 mLs, and we're looking for 5 teaspoons over X mLs. Now we simply drop the labels, so we have 1 over 5 and 5 over X. Now we solve for X by cross multiplying here. So 1 times that X and 5 times that 5. So X equals 25. So our correct answer is 25 mLs, or basically 25 milliliters. Now moving on to the next question. The provider prescribes a strict I&O, or input and output, for a client diagnosed with heart failure. The nurse empties the urinal of 5.5 ounces. How many mLs will the nurse document for output? Calculate your answer using dimensional analysis and record as a whole number. So first things first, what do you know? You know that 1 ounce equals 30 mLs, right? Or basically 1 ounce over 30 mLs. And what are we trying to solve for? Well, we're trying to solve for X mLs. So let's set up the equation. 30 mLs over 1 ounce times 5.5 ounces which was given to us in the question. So let's simply multiply across on the top. So 30 times 5.5, that gives us 165. And on the bottom, 1 times 1 is just 1. So 165 divided by 1 is 165. So the correct answer here is 165 mLs. On proper medication administration. So the real question here is how many ounces will the nurse instruct the caregiver to administer to the client? So we're doing dimensional analysis here and recording the answer to the nearest 10th place. Okay, so what do you know? You know that 30 mLs is 1 ounce, right? Or basically 30 mLs over 1 ounce. And always think, what are we trying to calculate for? We're trying to calculate for ounces. So put X ounces equals 1 ounce over 30 mLs times the 10 mLs because that was given to us in the question. Now we simply multiply across. So 1 times 10 is 10, and 30 times 1 is 30. Okay, so we have 10 on top and 30 on the bottom. Now we simply divide. So we get the grand total of 0.3. So our correct answer here is 0.3 ounces. Now moving on to the next question. The provider prescribes daily wound measurements for a client in a long-term care facility. The nurse documents 3 centimeters as how many millimeters? That mm right there. So calculate the conversion using ratio proportion method and record your answer as a whole number. So starting with the basics, what do you know? You know that 1 centimeter equals 10 milliliters. So put 1 centimeter on top and 10 millimeters on the bottom. Next, think what you're trying to calculate for. Well, we're trying to calculate for X millimeters. So 3 equals X millimeters, or basically 3 centimeters over X millimeters. Now let's set up the equation here. So we have 1 centimeter on top over 10 millimeters, and 3 centimeters over X millimeters. Now we drop the labels here. So we have 1 over 10 and 3 over X. Now we solve for X by cross multiplying. So when we cross multiply, X equals 30. So X millimeters equals 30 here. So the correct answer is 30 millimeters. Now for question 16. The provider prescribes daily measurements of a large open abdominal wound. The nurse receives reports that the wound is 37.8 centimeters in length. Now, the nurse needs to convert this measurement into millimeters for documentation. So what is the length of the wound in millimeters? So once again, we're using the ratio proportion method, and we're recording the answer as a whole number. So start with the basics. What do you know here? Well, we know that 1 centimeter equals 10 millimeters. So put 1 centimeter on top and 10 millimeters on the bottom. Next, determine what you're calculating for. So we're calculating for millimeters, right? So 37.8 centimeters equals X millimeters. 37.8 on top and X on the bottom. Now we simply set up the formula. 1 centimeter on top and 10 millimeters on the bottom, and on the other side, 37.8 centimeters on top and X millimeters on the bottom. Now we drop the labels here. 1 over 10 and 37.8 over X. Now we cross multiply here. So once we cross multiply, 10 times 37.8, our X now equals 378. So the correct answer is 378 millimeters. Now for the next question. The healthcare provider prescribes length measurements for a newborn in the nursery. So the neonate is 21.5 inches long. How many centimeters will the nurse document for the newborn's length? So we're calculating using dimensional analysis, and we have to record the answer to the nearest 10th place here. So start with what you know. We know that 1 inch equals 2.54 centimeters. So we put 1 inch on top and 2.54 centimeters on the bottom. Then set up the equation. What are we solving for? We're solving for centimeters. So X centimeters equals 2.54 centimeters on top and 1 inch on the bottom. Now you multiply that by the baby's length. So 21.5 inches on top. So now that everything's set up, we simply multiply across on the top as well as the bottom. So 2.54 times 21.5 gives us 54.61. And multiplying on the bottom is pretty easy, right? Because 1 times 1 is just 1. Now the division is really simple, right? Because 54.61 divided by 1 is just 54.61. Now the question is asking us to round, so we basically round down here. So 54.6 centimeters is our correct answer. Now for the next question. The nurse teaches a client about wound care upon discharge and demonstrates how to measure the wound. The wound at the time of discharge is 10.16 centimeters. So what measurement in inches will the nurse relay to the client? Now we're going to be using dimensional analysis and recording the answer as a whole number. So first things first, start what you know. We know that 1 inch is 2.54 centimeters. So put 1 on top and 2.54 on the bottom. Now we set up the equation. We're solving for x inches, right? So x inches equals 1 inch on top and 2.54 centimeters on the bottom. And we multiply that by 10.6 centimeters. Now that everything's set up, we simply multiply across. So 1 times 10.6 is just 10.6. And the same thing on the bottom. We get 2.54 because multiplying it by 1 is 2.54. Now we simply divide 10.6 on top by 2.54 on the bottom. So x in inches is 4.17. Now the question's asking us to use a whole number. So the correct answer is 4 inches. Now for the next question. The provider prescribes a medication that would be taken in milligrams per kilogram. Now the client weighs 175 pounds. So what measurement in kilograms will the nurse document? So we have to convert the child's weight using dimensional analysis and record the answer to the nearest 10th place. All right, so first things first, set up what you know. We know that 1 kilogram equals 2.2 pounds. So 1 kilogram over 2.2 pounds. And then what are you calculating for? Well, we're calculating for kilograms, right? So x kilograms equals 1 kilogram over 2.2 pounds, and then plug in the child's weight here. So 175 pounds. Now that everything's set up, we multiply across and multiply across on the bottom. And 2.2 times 1 is simply 2.2. Now's the easy part. We just divide. So 175 divided by 2.2, we get 79.54. Now the question's asking us to round to the nearest 10th place. So the correct answer is 79.5 kilograms. Now for the next question. The provider prescribes normal saline as a bolus 5 mLs per kilogram for a client after chemotherapy infusion. Now the client weighs 122 pounds. How many mLs will the nurse administer to the client? Now we have to calculate the bolus in mLs using the dimensional analysis method and record the answer as a whole number here. So first things first, set up what you know. We know that 1 kilogram equals 2.2 pounds. So 1 kilogram over 2.2. Then set up the formula. What are you calculating for? Well, we're calculating for x milliliters, right? X mLs. So x mLs equals 5 mLs over 1 kilogram times 1 kilogram on top and 2.2 pounds on the bottom. Then simply plug in the client's weight, 122 pounds. Now we just multiply across. So 5 times 1 times 122 is 610, and 1 times 2.2 times 1 is simply 2.2. Okay, now is the fun part. We just divide. 610 divided by 2.2. So now we get the grand total number of 277.3. Now the question is asking us to round to the whole number. So the correct answer is 277 milliliters.